Wednesday column of the week 4 independent practice asks that we factor the following. So factoring is something that you need to get really good at, because in high school it's a common practice that you factor through a lot of stuff. Now this is just the baby steps of factoring, so luckily we're just in the very beginning, but it is something you need to get really good at for high school. Now here for this first one, I've got 3x plus 18. So I just want to remind you that a factor factors are the numbers that can be multiplied by each other to equal a larger number. So the factors of 24, for example, can be 6 and 4, and then the factors of 6 are 2 and 3, factors of 4 are 2 and 2, and then we call these prime factors. Well, what we're going to be doing here is that we're going to be finding the factors, or we're going to be finding what two quantities we can multiply to give us 3x plus 18. So our answer should include two sets of parentheses, because if we do the distributive property, whatever number we put in here, we can distribute or multiply into the other expression to give us back our original number. Just like if we did 6 times 4, we'd go back to 24. So what I need to decide, though, is what am I going to factor out? What do this and this have in common? Well, they both have in common a multiple of 3. 3 and 18 are both multiples of 3, so I can factor out a 3. And then to get what goes in here, the opposite of multiplication when you distribute these is division. So you can divide both sides by 3, and 3x divided by 3 leaves you with just x, plus, don't change the sign, 18 divided by 3, that 3 came from over here, 18 divided by 3 is 6, and so I get that my factored version of 3x plus 18 is 3 times the quantity of x plus 6. And if I were to distribute that, I would go back to 3x plus 18. So hopefully that makes a little more sense as to what a factor is and why we are factoring these, how we factor these. On the next problem, we've got 2 and 4/10 y minus 48. So again, we're going to have two sets of parentheses, the number we take out, and then what's left over. So for this one, whenever you run into a decimal or a fraction, regularly what you're going to need to pull out, what you're going to need to factor out, is that decimal or that fraction. So as we get into more practice with decimals and fractions, then we'll start kind of throwing in some more difficult ones in there, some ones that require a little bit more thinking. But regularly what you're going to do here is you're going to take that coefficient, which is the number that's attached to the variable, and that's what you'll factor out. And to determine what goes in here, you'll just divide both sides by that number that you factored out. 2 and 4/10 y divided by 2 and 4/10 leaves you with just y, minus 48 and divided by 2 and 4/10, well, that is 2 and 4. I'm going to move that over once. I'll move this one over once. 24 goes into 48 two times, remainder of 0, bring this 0 up, and I get that 20. 2 and 4/10 goes into 48 20 times. And you could also have solved that by asking yourself how many times does 24 go into 48? 2 times, and then you would need to add just a 0 in order to solve that out. Here with the fraction, I'm going to do this next one with the fraction, and then we'll move on to the last one. I'll let you handle those two in the middle. So here on this one with the fraction, like I said, the only thing you can factor out of 1/2, well, you can actually factor a lot out of 1/2, but what we're going to be pulling out of this expression is the 1/2 itself. We're going to take out this coefficient, and then 1/2 divided by 1/2, that's just x. Plus, and then we need to do negative 14 divided by 1/2. We'll flip that. That's negative 14 times 2 over 1. Negative 14 times 2 is negative 28 over 1, which is really just negative 28. So on this one, we had to do a keep, change, flip because we were dividing a fraction. To divide by 1/2 is the same thing as multiplying by 2. And so we end up with our factored version here, which gave us a nice whole number at the end. So use that same kind of technique that we did here to do the next one, which is exactly the same kind of question, just without a negative. So hint, hint. And then you'll do the next one after that. You're going to pull out a 1/3. This last one, don't let this last one intimidate you. I know it's a little confusing because this x is already by itself. So what am I going to pull out of it if there's the only number attached to it is 1, but we don't show it? What you're going to pull out of this expression is the x, because there's an x on both sides. There's an x here and an x here. And so if there's an x on both sides of the plus sign, then I can pull out that x. I can factor out x. And then I can divide both of these parts by x. X divided by x, or any number divided by itself, is going to equal 1, plus 4y divided by x. This x and this x will cancel each other out and leave you with just 4y. And so we factored out a variable this time instead of a number. And if we were to do the distributive property here to really prove that these are factors, x times 1, well, that's just x, plus x times 4y, well, that's 4 times y times x, which is the original problem that we had up here. So this time we pulled out a variable. Yes, you can do that. And yes, you will be tested on that. You will be asked to do that again. So just kind of keep an eye out for that. If you see some x's, I also want to point out that the reason we don't just add these two numbers together is because these are not like terms. So even though they both have x, this has a y, and that stops it from being a like term. If it was x plus 4x, then we would add them together. That's 5x. But because this has a y attached, we can't add